Hello, I'm Kenjiro Nogawa from LINE. The topic of this presentation is features and optimization to support artists and fans. Before I introduce agenda, let me introduce myself. I joined LINE 2 years ago after graduating from university and working in the team for the development of entertainment service in LINE, doing server-side development for LINE Live and LINE Music. Recently, I am trying to improve performance in applications and interest in tools and technologies that will improve trust in services such as load test. Today, I firstly talk about overview of LINE Live. First half of the presentation is about new features developed in 2020 and the background mechanism. This year, in addition to developing new features, we implemented load test to improve service reliability. So the second half of the presentation is about what we do in the load test as well as creating an environment where developers can easily try load test. LINE Live is an application enabling everyone to enjoy video streaming and hosting such services. Celebrities and companies using LINE official account also provide video streaming. With chat, real-time communication between hosting site and user is available. From the point of services, when celebrities and well-known enterprises provide broadcasting, there can be a spike of access, traffic surge. In this graph, API request per second is increased by 10 times right after popular large-scale broadcasting started. After this slide, let me explain LINE Live background mechanism handling such spike of access. This is the overall architecture of LINE Live. There is a media server that receives video streaming from application. RTMP is used for the communication with the application of the broadcaster. RTMP stands for Real-Time Messaging Protocol, a protocol mainly for voice and video streaming. It is a protocol on TCP and has lower latency than HTTP. Media server receives RTMP packets delivered from the host. Then it transcodes the video file received to HLS format. HLS is an abbreviation of HTTP live streaming, and as it says, it is a transmission protocol on HTTP. Two types of files. One is segment file for voice and video, and index file including metadata of location and replay time are transmitted via HTTP. It runs on HTTP and goes well with CDN usage, so it is usable for broadcasting to large number of users. In LINE Live, index files and segment files are located in CDN, and users use the file obtained from CDN and replay it. Communications with API server is by HTTP request in JSON format. Communication with chat server is via WebSocket. This WebSocket connection is used for sending chat messaging and notification from service users as well as control messaging for real-time functions. Videos broadcasted from LINE Live is visible from Live application in addition to LINE Live application. So when a celebrity starts LINE Live video streaming, that video can be viewed via LINE official account without downloading LINE Live application. That means LINE Live broadcasting can be viewed by over 100 million LINE users. This often created a sudden spike of traffic from LINE users who receive the message of broadcasting. We use MySQL for database and Redis for cache. A lot of data is cached in Redis to handle spike access, saving MySQL resources to accelerate response. Kafka is used for asynchronous process execution. When the process is time-consuming and doesn't require synchronous execution, the job is handed to Kafka and consumer server executes that job. LINE Live service was launched in 2015, 5 years ago, since its release. In 2016, broadcast function is released to public users. In 2018, collaboration broadcasting feature enabling multiple users to simultaneously broadcast was released, and in 2019, features like subscription-based paid channels and paid broadcasting purchasable in applications are released. This year in 2020, large number of features are released than usual. Under COVID-19 in 2020, LINE Live development team followed two development lines. One is development of new features and functions. When many of the artists are struggling under COVID, it was necessary for us to quickly develop new features to support such artists. Another is performance, visualization, and improvement. Traffic has been increased due to stay-at-home request. Furthermore, more stable service operation is requested because we released ticket-based live streaming function this year. So it becomes necessary to quickly understand how much traffic can be handled in the existing system and challenges in it. From the next slide, I will explain new feature development and performance improvement one by one. In this presentation, I will pick up two features released in 2020, Face2Face and LINE Live Viewing, including its mechanism and concept. LINE Face2Face provides a feature so-called Akushukai online. Fans of the celebrities can enjoy one-on-one communication without visiting the physical site. Users can talk with the celebrity until allocated time ends. Time allocated is calculated by the number of tickets based on the code input, distributed in advance. Users wait in a queue while the other user is talking, and when all the users who enter the queue before you finish, you can start talking with the celebrity. Video call is implemented by RTMP. As I talked before, RTMP is a protocol on TCP and has lower latency than HTTP. Communications between fans and an idol is implemented using two RTMP streams. Media server or RTMP server generates RTMP URLs, respectively for fans and an idol, and distributes them by WebSocket connection. Idol side transmits packets using RTMP URL for the idol, and a fan receives the packets using RTMP URL for the fan, which enables or establishes communication. Face-to-face is implemented in 4 procedures. Let me explain one by one. First, a fan enters one or more ticket code purchased in advance and is registered in a queue for fans. This queue is implemented as tables on MySQL. When Face2Face is launched on idol side, batch server gets information of the fan from the queue. Then batch server gets 2 RTMP URLs from media server, one for the fan and another for the idol. Then RTMP URLs are transmitted to the fan popped from queue and to the idol via WebSocket connection established before. At this moment, allocated time duration for the fan is also noticed to idol side. Between the fans and the idol who got RTMP URLs, transmission and receipt of RTMP packets starts and video communication is established. Idol side calculates time, and when the fan's allocated time is finished, hits end API and the session is completed. Batch server repop information of a fan from a fan queue and repeats the same flow until queue size reaches 0. Face-to-Face was developed taking advantage of collaboration broadcasting, one of the existing functions. With collaboration broadcast features, users can view a video call between two broadcasters. Notification by RTML URL and WebSocket in the last slide uses the same mechanism as this collaboration broadcast. We can say that Face-to-Face continues collaboration broadcast in loop as long as user remains in a queue. Our standard development scheme is a repeat of plan, review, and develop cycle with a short interval in parallel like semi-waterfall. To cope with COVID-19 situation, development side joined and aggressively involved from planning stage to accelerate the process. Since this feature utilizes existing collaboration broadcast, engineers who have good knowledge about specification and implementation of the collaboration broadcast aggressively joined to take effective advantage of existing resources. Another feature developed in 2020 is LINE Live Viewing online ticket-based streaming. Users can watch live or archived broadcasting in LINE Live or LINE application after purchasing online tickets sold in advance. Many well-known artists started to use this feature for broadcasting right after the release. LINE Live Viewing feature is available in LINE Live application and website, just like the case of LINE Live. When you buy a ticket after logging into LINE on a ticket sales site, the LINE account is authorized to view, and then you can view the broadcast on LINE Live application and LINE application. One of the issues in LINE Live viewing is traffic spike. Since number of tickets sold is limited, we assume there will be a traffic spike at the timing of sales. LINE provides a ticket sales service called LINE Ticket. From the operational experience of this service, we know we should pay attention to traffic access at the start of ticket selling. There is a spike of traffic not only in ticket sales but at the time of viewing because many users start viewing right after the start of broadcasting. To tackle high volume of traffic at ticket sales site, we frequently use caching in Redis, in-memory key-value stores, from the top screen to ticket purchase site. By reducing access frequency to MySQL for reference as less as possible, load to MySQL server is reduced and response time is lowered. In the session about ticket sales site at ISCON, a website performance competition, a case of caching in Redis is used as a sample answer. We take the similar strategy to reduce load. For example, all the information presented as a list of events on the top page is gained from Redis. In the case of new arrival list as an example, batch server sorts a list of events per minute from the newest in MySQL and stores it in Redis zset. We use zset since in zset is finished sorting and allows high-speed paging access. For high-volume traffic handling at the start of broadcasting, asynchronous data update is used in addition to caching in Redis. Ticket has a status information to show whether the ticket was used. When a user used a ticket to view streaming, the ticket status needs to be upgraded, but such upgrade does not have to be synchronous, so we just set a flag of view record in Redis. When user viewed broadcast and update the status after broadcasting is completed. I mentioned LINE Live uses Kafka for async processing, but in this case, in order to avoid high volume issuance of Kafka job due to a spike right after the start of streaming, we use async processing using flags in Redis.
After such performance tuning and before the production release, we carried out the load test for the ticket purchase flow. Well, this will be covered later on. The access to the home, to the ticket purchase, this flow is the scenario, and then the many scenarios are executed in parallel for the load test to see the spike. So we are able to accommodate 200 per sec, and based on the track record of LINE Ticket, we thought there would not be much issue for the time being, and since then, we are stably accommodating and processing traffic. Just like the LINE viewing, so before using this kind of the new feature service, we need to conduct the load test, but it it also is important to continue the load test after the release. So I would like to introduce the load test that we are addressing in LINE Live. In 2020, we had the big turning point in phase for the LINE Live project because the requirement has increased attributable to the three major reasons, and we needed to increase the reliability. This year we launched the LINE Live viewing. The tickets are sold before the broadcasting. Therefore, the UX has to be more stable during the broadcasting, and the thinking about the service growth and also the stay home orders due to the COVID-19, we can expect the more increase of the traffic. And lastly, early this year, we experienced a large incident, and based on those reasons and causes, within the development team, we started to make the reliability more robust. Earlier, I talked about the issues, the large incident. Actually, the more than 3 times of the normal peak traffic came, and we had so many concurrent viewers. API server keeps the MySQL connection while processing a request, and also the Redis traffic is overwhelmed with unnecessary key values, and the bandwidth reached the cap, and it became unstable for more than 1 year. It's very difficult to discover this at the code level test, and also in LINE Live, when we have a large broadcasting, the tens of times bigger traffic will come, so it's very difficult to forecast from the monitoring of the normal load. Therefore, in order to discover the latent issues, we decided to have the load test that applies the artificial load. Our purpose is to test the irregular large-scale broadcasting requests, and we need to stably process those requests. In order to do that, we have to apply equivalent or more load, and such performance needs to be analyzed, and if there are issues, we have to fix it, and this process needs to be iterated. And this process is the expected load, equivalent or more load needs to be applied. That is the key point. First, normal load is not enough. Large broadcasting load, well, actually, normal load is less than 1/10 of that. Therefore, the performance analysis of the normal load cannot really discover many issues. For example, the connection leak issue, the depletion of a connection pool becomes very serious only when the number of the concurrent users and the viewer increases. And also large broadcasting in the production environment, you can have the sufficient load, but this event is held maybe 1 month apart. Then if you are waiting for this, then the overall performance improvement process slows down. For example, measuring the impact of the improvement. On the other hand, load test can be performed anytime with the high load. So you can accelerate the improvement process, and you can adjust the load. For example, the extreme workload can be applied. In the future, of course, we may face the such extreme load. So this is a big benefit. For those reasons, we have focused on the continuous load test execution on the existing system. As we perform the load test, there are a lot of considerations in operations, and we focus on the 3 main points. First is the repeatability. It's easy to test anytime under the same conditions or different conditions. We can conduct a test easily, then we can accelerate the process of the improvement and the analysis, and it reduces the burden on engineers. With less engineer burden, then we can continue the load test. That is very important. And LINE Live has actually performed the simple load test before the release of the new feature, but the script was not shared and it wasn't repeatable. Therefore, we couldn't really run the continuous improvement process. That's why this time we are focused on the repeatability. And the second is understandability of the result. After the execution, we receive the result immediately and use that for the further analysis and improvement. Even if it is easy to execute, but it takes so much time to understand the result, then we can't really run the improvement process quickly. And lastly, the editability, editing the existing scenarios or easily adding the new scenario will be important, and we can really avoid a situation where the result of the test doesn't make sense. Line Live application usually have the update once in 2 weeks or sometimes once a week. So scenario maintenance cost is important. To secure the repeatability, Line Live load test can be performed on the Slack. We have the dot stress, reserved word, and also scenario ID can be entered, and the execution server will receive the request. Scenario parameters can be stipulated. So for example, we can set the 5,000 viewers for the application broadcasting. So without having so much burden on engineers, we can easily conduct a test. And alpha, beta, environment deploy can be done on the Slack with the Line Live. So just like that, we can conduct this load test, so new members can easily do that, and the learning cost is very low. And the second one is understandability. So result report is sent to the Slack, and that report includes the 3 types of the information. The top one is the pass or fail of the load test. So it's important to quickly understand whether test was passed or not. And how is it defined? API response status code is 200, and the response time percentile is less than the threshold. The Line Live scenario threshold is 1.5 seconds. And the second information is a client-side metrics, per sec request or the request per sec, and also response time percentile values per API are responded. And the third information is a server-side metrics. This is displayed as a Grafana graph, load average, CPU usage, server resource, and also the incident. For example, the MySQL connection count are prioritized to display. Looking at such result, we can use those for the basis of the further analysis. And editability is very simple. Scenario can be pushed to Git repository or edited, and the automatically application side scenario is updated. So far I explained about what's important in our load test. Now I would like to talk about the tools and the system architecture. Load test execution engine, we use the OSS load test tool called K6. With K6, we can write a scenario in the JavaScript compared to other open source tools. Virtual user number, the unit of the concurrent execution, that can be easily addressed. However, we have our own implementation across the multiple features. This is the overall system architecture of the load test bot API. This is the Slack bot backend for application deploy. Receive the signs for the execution, and the request is sent to the execution manager, and the execution manager assigns the test node processing, and the test node uses the K6 for the test. After the test, execution manager notifies the result to the Slack, and the K6 output default report and each API's response percentile. Those unique values are included in this report, and also the Grafana dashboard URL of the test execution section is sent, and the bot detects this if it's attached to the Grafana or the Slack report with the URL, and it's uploaded. There are 2 types of the load test. One is the API unit test. API performance test is visualized. That's the purpose. And we're not doing this for all APIs. We are just testing the ones that are frequently called out. And another is a scenario test. System performance of the expected scenario is visualized. For example, at the time of the broadcasting, the spike from the application play. the server with the load is separate from the beta environment and the real environment. We prepare the load environment to apply the load. The server instance number is 10% of the real environment. Well, ideally, it's better to have the same number as a real environment. It's easy to analyze the result, but the live production environment has the hundreds of instances. So because of the cost, it's now 10%. After starting the load test, we discovered several issues. Applications viewing scenario load test was worse than expected. We investigated and we found the API that had extremely poor performance, and we scrutinized, and the N+1 query was issued because of the recently added code. For example, the gift item, the viewers can send the items to the distributors, and this API returns a list of the items, and it was issuing the query based on the number of the items, and that was the degradation point. And also, application viewing spike access scenarios test, if there is the immediate load, then the MySQL connection pool deplete, and we investigated, and the issues of the connection handling was not solved. And it's been only 1 month since we started this operation, but we are able to detect such performance issues, and also we are able to have the numerical base. This much traffic can be accommodated, so I believe that the server-side engineers' psychological burden was reduced. In this presentation, I talked about the scenes behind the 2 new features that was developed in 2020, and also load test to support the future growth. We focus on the repeatability, understandability, and the editabilities, and the tools and architecture to realize them are also covered in this presentation. Load test shouldn't be just carried out before the service, but after the release, you need to keep improving the performance, so it's very effective. So we have just started, so we are making trial and errors. So we will accumulate the knowledge and experiences to address this. LINE Live will continue to introduce our knowledge on the blog, such as what's happening about the new features and application improvements. So please check them. Thank you very much for your attention.